So now we want to look at another example here of finding the derivative with the chain rule. And again, we use the chain rule to deal with composite functions. That's when we have one function inside of another. This could get really extremely awful messy if we ever tried to go back and use our full-blown limit definition on this. That might be pretty bad. So this is a composite function. First off, though, before I set about doing the derivative, with the square root, I'm better off writing that as a power. So remember, square root is to the 1/2 power. So I get 1 plus x squared to the 1/2 power. And now I can talk about this as a composite function. I can see very clearly I have that expression on the inside, 1 plus x quantity squared. And so I go ahead and say, okay, well, u be that stuff. And if I replace that 1 plus x squared with u, I would just have the expression u to the 1/2. So the outer function is u to the 1/2. The inner function is 1 plus x squared. And so this time we're going to write out the detail just a little bit less detail than I put the first time. So rather than doing the df du, du df that I wrote down the first time, I'm just going to go ahead and jump right into taking the derivative of u and the derivative of f. So the derivative of u with f with respect to u. So derivative of u to the 1/2. Right, that's my f. And then times the derivative of u, my u expression, in terms of the variable x. So I have derivative of u to the 1/2 times the derivative of 1 plus x squared. And we go through and do our derivatives. So derivative of u to the 1/2 would be 1/2 u to the minus 1/2. And derivative of 1 plus x squared, derivative of 1 would be 0. Derivative of x squared would be 2x. And there's a little bit of simplifying that we can clean up, right? The 2's and the 1/2 there will cancel out. And so we'll have x, and instead of u, I'm going to replace that with the quantity, 1 plus x squared to the minus 1/2. Now there is one further step that we're going to want to do. Generally speaking, we don't like to keep answers with negative exponents as a final result. That's kind of by convention. That's the society rules that we have to follow. And so we take that stuff to the 1/2, and we're going to need to move it to the bottom. Now, when we move it to the bottom, we'll have 1 plus x squared to the 1/2. And you're perfectly fine to write it that way. I generally take my unit fractions, 1/2, 1/3, 1/4, and so on, and transform them back into a radical. Whereas if that had been 2/3, there I would just leave it as that stuff to the 2/3 power. So that's kind of my own little convention. I like to take my unit fractions like 1/2, 1/3, and turn them back into the radical. Otherwise, I leave them as a fractional exponent. You could do it either way. So you could have written x over 1 plus x squared, all that to the 1/2 power. That would be fine. Or we could write it as the square root. Okay. Let's consider this next example here. F of x equals sine of 2x. This can actually be done without the chain rule, because you do have a trig identity, a double angle identity for sine. It says sine of 2x is 2 sine times cosine. And then you could work through the derivative of 2 sine cosine using your chain or using your product rule. But we're going to treat this as a composite function. Here we have the function sine, and inside of the sine, instead of just an x, we have that 2x function. So u is 2x, and f becomes sine of u. U is 2x, and f becomes sine of u. Hopefully you're starting to get comfortable here as we work through our third example here at the chain rule of dealing and recognizing parts of a function, a composite function. So at this point we set about doing our chain rule. F prime is the derivative of the outer function, so derivative of sine u times the derivative of 2x. Really want to stringently encourage you, write out this detail right now. Make yourself do it. I see students, they'll be okay with stuff when we cover it. They won't write down a lot of detail. and then it comes to a test, and I'll just see mistakes all over the place. If you make yourself write the detail out now, it'll help you to kind of handle and manage these situations when you encounter them again in the future. So here we just have to do the derivative of sine of u. We know derivative of sine is cosine, and we need to do the derivative of 2x with respect to x. And so we go ahead and do that. So that's going to be cosine u times 2, but we know that u is 2x, so our answer is 2 cosine of 2x. And if you were to go back and working with that sine 2x identity and did the derivative of 2 sine x cosine x, you may not exactly get cosine 2x, 2 cosine 2x, but you should get something that's equivalent to it by some trig identity.